Section 3.1, functions and function notation. Let's start with just some terminology we all need to be familiar with. It's not something you have to have memorized, but when I say it, you need to understand what it means. So if there's anything you don't know, you may want to jot down some notes on it. First, let's talk about what a function is. A function is a correspondence between a set of input values, called the x's, and a set of output values, called the y's, where to each x value, there corresponds exactly one y value. You may have memorized this a different way. You probably learned what? Remember what a function is? Function is a relation where the x's do not repeat. Yeah, don't repeat. So that just means that you can't have two different points like 2, 5 and 2, 7. Because then it wouldn't pass the vertical line test. So also remember that a function has to pass the vertical line test. Then let's talk a little bit about domain. The set of all the input values, in other words, the set of all the x's, is called the domain, and the set of all the y's that comprise a relation is called the range. And we typically give both of those in interval notation when possible. So if it's possible, we'll give those in interval notation. Well, the first thing we want to do is we want to be able to look at an equation and tell whether or not it's a function. This is probably something you haven't done before. So you want to be able to look at an equation and tell whether or not it's a function without actually having to graph it. The best thing I can tell you is that if you solve it for y, if you get a plus or minus, it is not a function. So if you imagine solving it for y and you get a positive and a negative, a plus or minus, it is not a function. Another way, I guess, to say it is not a function if you have absolute value of y or y to an even power. These guys are not functions. Pretty much everything else we deal with in college algebra is. So you kind of need to take note of that. It's not a function if you have the absolute value of y or y to an even power. So for part A, we have 7x plus y equals 5. Notice there is no absolute value on the y, and the y is not to an even power, it's to an odd power. So that one's okay. So this is a function. Here we do have absolute value, but it's on the x, and it's okay to have absolute value on the x, just not on the y. So this is a function. This is the one that turns out not to be a function. It has an even power on the y, and it forces it not to be a function. And if you remember graphing these, this will graph as a what? A line. This one will look like a V. But what does something that has a y squared look like? It ends up looking like a sideways parabola. And notice, we learned that last unit, that does not pass the vertical line test. So that's why it is not a function. Now we want to talk in a little more detail about the domain of a function. We've already said the domain of a function is a set of all the real numbers x for which the function is defined. So to find the domain of a function, we have to find all of the numbers that are permissible inputs for x, which means we first have to consider any restrictions. So that's why we started out this whole semester at the very beginning talking about restrictions on our x's. So when do we have restrictions? We know that we have restrictions when there are variables in the denominator. And we also have restrictions when there are variables under a radical. Is it just any radical? How about an even radical? You have just restrictions on square roots, fourth roots, sixth roots, but you don't have them on cube roots. You only have restrictions for even radicals. So be sure that you understand that. Just a quick review. For the next example, we're going to find the domain of these three functions. We're going to start with part A. Part A says that y equals 2x minus 5. What type of function is that? We just finished studying them. If you graph it, what does it make? A line. It's a line with positive slope, right? Does that line have any restrictions? No, there are no restrictions. There are no restrictions because there is no variable in a denominator. In fact, there's no denominator at all. And there's no square root or fourth root or sixth root. So there are no restrictions on this. Because there are no restrictions, that means that x can be anything at all when we graph it. So therefore, our domain is said to be all real numbers, from negative infinity to positive infinity. If there are no restrictions, then the domain is simply all real numbers, and that's notated from negative infinity to positive infinity in interval notation. Now for the second one, y equals the square root of 3x minus 2. To find the domain, you first have to identify the restrictions. And we know that in this, the square root's not allowed to be negative. In fact, it has to be greater than or equal to 0. So that's how you start. You start by taking what's under the square root, setting it greater than or equal to 0. And then you just solve it. 3x is greater than or equal to 2. X is greater than or equal to 2/3. This tells you what x can be. X cannot be less than 2/3. And your domain is what it can be. So x can be greater than or equal to 2/3. Then you simply write that as an interval. So that would mean there should be a bracket on 2/3, and that goes to positive infinity. Anything between 2/3 and positive infinity is acceptable there. But if I put in anything else, I will get the square root of a negative. So for example, if I put in 0, if I put 0 in here, I would get the square root of -2. And that would not be defined on my graph. So we want only the numbers that will give us a place that is permissible on our graph. So everything greater than or equal to 2/3. Y equals 3 over x plus 2. What's the only restriction on this? So we say x can be anything. It just cannot be -2. I need to figure out a way to write that as an interval that says everything except -2. The way you write that as an interval is you say it's everything until I get to -2, but it doesn't include -2. So you put a parenthesis there. And then it's everything after -2.
So it's like a little open dot thing.
Mm-hmm. So if you thought about it as a number line, what you're basically saying is that x can be anything except -2. And the way you show that is to put parentheses there, and everything else is okay. So if you need to see it on a number line in order to write it as an interval, you can. But basically, you just break it from negative infinity to infinity, but you break it into two separate pieces, and you break it at the restriction. We say it cannot be -2. Now up here, this one had a bracket, and in fact, you may want to go ahead and know that square roots will always have a bracket on one side, whereas the ones with variables in the denominator won't. You're not allowed to have a variable in the denominator there, so it becomes a parenthesis. For this example, we have y equals 1 over x squared minus 5x minus 6. To find the restrictions, I need to go ahead and factor the denominator. That factors into two binomials, x, 1 plus 1 minus. So I need two numbers that multiply to -6 but subtract to 5.
-6, +1.
-6, +1. So you have to be really careful. A lot of people forget and they try to use 2 and 3, but that would only work if they were both negative. So be really, really careful with that. And that gives us the two restrictions. X cannot be +6 or -1, but it can be anything else. So it can be anything. It just can't be -1 or +6. So you can imagine it with open circles or you can imagine it with parentheses there. It really doesn't matter. But everything else is okay. So here to here, here to here, and here to here is okay for your domain. So we actually have 3 intervals for our domain. Everything from negative infinity to negative 1, everything from negative 1 to positive 6, and everything from 6 to positive infinity. So that domain turns out to be a lot more complicated than some of the others. When there are 2 restrictions, you're going to have 3 intervals. What do you think? How many intervals do you think there would be if we had 3 restrictions?
4.
Yeah, there would be 4 intervals. So there's always one more interval than there are restrictions.